So far, we have been looking at theoretical probability, which is a logical guess of the chance that something will occur. So we're basically saying what should happen. Whereas today, what we're going to be looking at is experimental probability, and this is to test the chance that the possible outcomes occurring using actual materials. So what we're saying this time is what is actually happening. We're going to be using a few different formulas. So we know that when we look at probability and calculating probability, we use this formula here, and we can also use this one here, but this time we're looking at the probability of an event equals the frequency of events divided by the total frequency. And when we refer to frequency, we mean the number of times something happens. We're also going to be using this formula here, which is to calculate expected frequency. And expected frequency is the number of times an event will occur over repeated trials. When we look at probability and we look at experiments, the more trials that you do, the better the outcome and the better prediction you're going to have of what the outcome could possibly be. So to calculate the expected frequency, which is here, you will need to multiply the theoretical probability, which is what we've been calculating as fractions, times the number of trials. And the greater the trials, the better prediction you're going to have of the outcome. Let's look at an example. So Selena spun this spinner 80 times and found the following results. So she actually spun it 80 times. And within those 80 times, 44 of those times she got a red, 25 of those times she got a green, and 11 of those times she got a yellow. And if you look at the actual wheel, that makes sense. There's a lot more yellow components on the wheel, red components on the wheel compared to yellow. And so you would want to see a higher number. And again, 80 times is a good number of trials to be able to get a good prediction. The question asks, what is the theoretical probability of spinning red? So we're going to do what we've been doing so far. So the probability of red equals, now how many times does red appear on the wheel? So let's have a look. We've got 1, 2, 3, 4, 5. So that's my favourable. Okay, so there's 5 altogether. And we're going to divide that by total. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 over 10. And that can be simplified to a half by simplifying our fraction. So the probability of getting red is 1 over 2, or 0.5, or 50%. Part B says for 80 spins, what is the expected number of times of spinning red? How does this compare with the actual number of times? So what we're going to do is use that formula that we just looked at. We're going to look at the expected number of red. So the theoretical probability is this number here. So half. And the number of trials is 80 because she spun it 80 times. So a half times 80 will give me the answer 40. So that we should expect for 80 spins that we get 40 reds. However, you can see in our experiment we actually got 44. So it's pretty close in terms of what the trial is. But this tells us what the expected number is, and we can compare that to the real number, which is 44. So it's off by about 4. The last part is, what is the experimental outcome? So what we're going to do here is we're going to do probability of red equals the number of times that we actually got, which was 44, because that's what actually happened in the experiment. It's not just in theory, divided by how many times we actually did the experiment, which was 80. And we can simplify that to 11 over 20. So as you can see, we can use different formulas to predict what we think should happen, and then we can use different formulas to see what actually happened and compare that, and then also find the probability of what actually happened as well. So it's important to use these formulas carefully and to use them relevantly.